Hey guys, it's Mr. H with A-Level Tech. Yes, I know I'm just like a floating box that is somewhat see-through at the bottom of your screen. Yeah, see? Hey, it's me. I'm down here. Anyway, we're going to take a brief, maybe 10 to 15 minutes and talk a little bit about magnetic fields and how that affects electrical circuits and how modern vehicles operate. Not just modern vehicles, but just vehicles in general. We can go way back when we were talking about generators and just how electric current flows, because there was no point where electricity was just boom, hey, we created it. No. There's always been thunderstorms, there's always been electrical charges. But let's talk a little bit about magnetic fields, because while we were in class, we did talk a lot about how to use a DVOM and how to backprobe circuits and looking at series circuits and parallel circuits, not to mention ATEC. But let's talk a little bit about magnetic fields, because we didn't really dive into a whole lot of that yet. So let's take a look. Right now, if you want to follow along, definitely take notes, pay attention, because there will probably be a worksheet going along with this video. But we're in chapter 25, we're in section 6, as you can see in front of you. So right there, we're talking about magnetic fields. I am not going through the whole entire chapter. I am just focusing more along the lines of a magnetic field, electromagnetism, and how that really has anything to do with us as automotive technicians and what we do for a living. But anyway, if you go through this chapter and you get to this point in 25.6, we talk about magnetic fields. Now, I'm just going to read a little excerpt out of here. So, magnetism is used to produce electrical current in the charging system. It is also used to make starter motors run. Electric fuel injection systems and electric automatic transmissions both use magnetism to operate injectors and solenoids. So, any of those. So, when we were in the bench, when we were doing our task sheets in the shop, and we were looking at the different kind of motors that we had, whether it was a starter motor, alternator has very similar components. You'll see that just a little bit of backwards in the way that they are dissimilar. We also looked at fuel pumps, relays, solenoids, things like that. So, anything that's on a vehicle nowadays, even down to, VVT, because that's, back in the mid-2000s, everyone was stamping that like a label of approval. Boom, you have VVT. That means this car is super awesome, VTEC. A lot of those systems, they use solenoids. A lot of them used all these different types of components that use a magnetic field for the most part to actually perform work. So we use the electrical current to go through. Now, here's the part where we're going to start talking about how things work. Through a coil of wire that was either wrapped around, let's say, an iron core or a core of some sort to produce or induce a magnetic field and voltage, or a higher voltage. So let's keep going on. Let's see what else they have to say about it. A magnet is a material that is, will attract iron, steel, and a few other materials. Many of the laws that govern electricity also govern magnetism. Go figure, that's why we probably use them. Cool. All right, magnets have polarity, which allows them to hang free, will align themselves with north and south. The north-facing end is toward the North Pole, south face to south. I'm hoping you guys have put that together by now, but anyway, let's keep going. Like poles repel each other, and unlike poles attract, so I'm going to kind of scoot down here. I'm going to bring down the page. So this is your basic real rudimentary way of looking at a magnet and how the fields attract and repel, so on and so forth. But what does that have to do with anything that we are doing? Well, let's take a look at the next page, shall we? All right, now we're talking about electromagnetism, a magnetic field created outside of a conductor. So that's important. It is a magnetic field that's created outside of a conductor. Notice it didn't say inside. It says outside of a conductor that has electricity flowing through it. So, magnetic field outside the conductor that has electricity flowing through it on the inside. Outside, inside, outside, inside, outside, inside. Remember that. That'll come into play probably in, I don't know, maybe a worksheet? No way. It means you gotta pay attention. All right, let's keep going. When the wire is coiled, a magnetic field is made stronger. So let's say if I took, a strand of wire and I had it as, whatever you want, it's series circuit, parallel circuit. But anyway, electricity is flowing through that. That still has a little bit of a magnetic field. Otherwise, You know, why do we use an amp clamp or an inductive current clamp? Well, how do we get those numbers? Well, there's a little bit of this magic that goes on when you're using tools like that. But anyway, let's look a little further. When the wire is coiled, the magnetic field is made stronger. Adding an iron core to the inside of that wire will concentrate the magnetic field, making it even stronger. Increasing the number of coils increases the strength of the field. The strength of the field is also related to the amount of current flowing in the conductor. The stronger the magnetic field can be obtained in the same current if there are more coils of wire. So that was a lot of words. Now let's see what that actually looks like. So we're seeing in a lot of these, now you have the same book I do, so I'm not going to spend too much time narrating what these pictures look like. But basically what they're showing is, you know, if you take a wire and you kind of loop it over itself over and over again, you're increasing that magnetic field. Now, when we were talking about putting, let's say, an iron core in between, now we drastically amplify what that magnetic field could be doing. And this will be the basis of just about everything that we will talk about from 161 into 166. So we're talking about any motors, any solenoids, any step-up transformers. So, you know, coils, ignition coils. It's just a step-up transformer. That's all it is. We're just stepping up that 12 volts to kV just so we can actually jump the gap for a spark to happen in the ignition system. So, this picture, right? Oh, it's backwards, so it's got to be this way, right? Yeah, that one right there. Remember that, because that is just the basis. Now, there's going to be primary and secondary windings in some of these coils. Obviously, that's a little different, but when it comes down to it, this picture right here is the basis for how all of that works. So adding an iron core in the middle amplifies this magnetic field drastically. And when I say drastically, well, if it didn't work, obviously we wouldn't have, you know, step up or step down transformers at all. So obviously it's got to work. And then they go into this little spiel about magnetic field strength is determined by the amount of current flowing through the number of coils. The two examples shown below, you know, the amperage needed in one turns in proportion to the last, blah, blah, blah. You get the idea. Here's our math once again. You can't escape it, guys. Math is the rest of your life if you want to be an automotive technician. I know. It's a harsh reality, but hey, you guys are electricians, physicists, chemists, plumbers, just about anything, HVAC. That's all you. But anyway, let's take a look here. So if we're looking down here, we can see, you know, okay, if 1 amp of current is flowing through 1,000 turns, you can see that would be the same as, you know, 10 amps flowing through 100 turns. So it just depends on, you know, how many amps versus how many turns. They can equal out depending on which one's higher and which one's lower. But this is where we get these basic principles from and how this works. So another thing, and I think this is probably going to be the last thing I'd be able to fit in this video, is, okay, well now what? Now I know about an iron core, and then we wrap the wire around and flow electricity. Okay, boom, bigger magnet. I get it. Now what? Let's talk about electromagnetic induction now, which is pretty awesome. I'm not going to lie. It's pretty awesome. Now we get to actually do work with that magnetism. So electricity can be produced by moving a magnetic field over a conductor. The polarity of the magnetic field pushes electrons through the conductor as the field is moved over the conductor. Sounds a little confusing. That's okay. You're just learning. This is the basic principle behind the operation of AC generation that charges a vehicle's battery. AC generation, that's right. You guys did a task sheet. You remember you took apart that alternator. We were talking about the poles, you know, north, south, and they look like shark teeth on the inside of that rotor. Now we can actually figure out how does that actually induce anything. Now we're getting somewhere. See, we're making the connection. We're making the connection now. Okay, so electromagnetic induction is also used to produce spark in the ignition system. So anytime we're doing that, anytime we are pushing electrons through a conductor as the field is moved over the conductor, so that magnetic field is being moved north, south, over the conductor over again, we're inducing current. We're actually inducing a voltage, inducing a current that way to, let's say, make alternating current that is flowing through that alternator. And, then we finally get to the diodes and the rectifier bridge. And, once we get to all of those other components, now we're going to slice that waveform in half and make it DC, because let's face it, AC does not really help our battery situation whatsoever, especially when we're trying to recharge and replenish a battery with electrons, not let it go back the other way. That would, parasitic draw is what that would be. And that does happen when diodes start to fail. But anyway, now we get the idea. Now we can connect the dots between who cares about, spiraling a wire and magnets? What does that mean to me? Well, that is these basic principles that are up here in these last 2 pages that I talked about are the basis for everything that you have done on your task sheets as far as rebuilding a starter, looking at brush motors, looking at an alternator, any of those systems. Now you should be able to kind of connect the dots as far as, okay, well, now those magnets make sense. Now that I was looking at those rotors and they were talking about the north and south poles that go in between that close air gap to induce a current. Okay, now I get it, Mr. H. Now it's starting to make sense. It's not just parts that I'm taking apart and putting it back together. Because let's face it, that's the whole reason of your schooling right now. It's very easy to just take an alternator. Okay, parts. Okay, put it back together. Cool. Did I learn anything about how it works? Nope. Well, now we can actually connect the dots using this theory right here. So as you're going through these chapters, even though that was just a really short video, I wanted to make sure we kind of talked about electromagnetic induction, electricity, and magnetism. So it kind of slowly builds together as you're going through here and you understand how this stuff works. Because once we get into 166 and we talk about, let's say, primary and secondary ignition and the ignition coils, how they act as step-up transformers, as we talk about those windings, those really fine windings, both on the primary side and the secondary side, in an actual ignition coil. Hopefully it starts to, well, not hopefully, it should cross over from the theory from 161 into 166, making a nice fluid transition as we talk about these different benefactors that affect how current can change, how induction can actually cause current out of nothingness. No, not nothingness. It's not magic. It's just really the basis of electrical and physics and how everything works. Not to mention, if we didn't have the raw materials, so even though it is not crucial that you guys understand, in this chapter, they're going to talk about the different types of conductor. They also talk in 25 about, okay, well, this would be a good, conductor because this can shed electrons freely and give them back and forth. And we talk about the periodic table. I still remember when I took advanced chem, and I don't know why I made that decision in high school, but I took advanced chem. I still remember every single element on the periodic table. There was a little trick that they taught us to remember everything: high halobibkanov, Unimide, Gauss-6 chlorine, and so on and so forth. So I could still write out the periodic table. Does that actually serve a purpose? Not really, not at this point in my life. But understanding those different elements and how they affect how current flows, why do we use gold in circuit boards? Why do we not use it in wiring? Is it malleable metal? Does it flow as well? Can it give electrons as freely as other metals? As well as, using an iron core. Why do we use an iron core? Why do we use an iron core to actually be in the center of that magnetic field? Things like that. You're not going to get that if you don't understand this theory. So make sure you guys do take the time and read through these chapters. Even though I only went over 2 pages, you still have the whole entire chapter. So kind of go over it with a fine-tooth comb, because there will be more videos, there will be more worksheets. Hopefully you got something out of this little chat we had about electromagnetism. But when you're using, let's say, you're testing a battery and you're using the amp clamp or the induction clamp or probe, whichever you want to call it, now you might understand that, oh, electrons are flowing through here, therefore there must be a magnetic field that I can kind of clamp over, and through a whole bunch of variables I can understand using a formula how that translates to, oh, now it knows that there's 5 amps flowing through that current. How does it do that? How does it know that? If you understand the basics of that, that will help in the long run. But anyway, that's Mr. H with A-Level Tech for today. For these little 2 segments. Hopefully you got something out of it. There is a worksheet, so hopefully you paid attention.